So let me start my session. As we all know, today we are basically going to cover a very high level overview of what is big data, why big data is such a big buzzword in the industries these days, why a lot of organizations are spending huge money in big data space to solve some business problems using big data, and why Hadoop has become the most efficient technology to work on big data, right? So let us try to understand all these concepts, and along the journey you can always stop me and ask me any questions if you have, but I would request, since it's we have opened it for a large set of audience, so if you have any questions, if you can pause it for a while or hold it for a while, I will give you a time at the end to ask your questions. There will be about 10 to 15 minutes of a time that I will give to all of you. Will be an open question and answer sessions. Right, you can ask me any questions related to these technologies and I'll be happy to answer them. All right. But if you think that it is very critical, you cannot hold it, then please ask me the questions on the way. All right. So does that make sense? Is it fine with everyone? Okay. So before I start, let me introduce myself. First of all, thank you all for joining this webinar, spending this time, precious holiday time, and I think that really shows that all of you are so passionate about learning these technologies. So I must appreciate your motivations behind that. So let me introduce myself. I am Jaimin Patel. I have over 10 years of experience in software industries. I have worked with a couple of product development companies who work on building softwares. I have used technologies like Java, J2E frameworks, Spring, Hibernate, lot of technologies which these days people use to build softwares and sell softwares. Typically, I'm by heart I'm a developer. I like to get in touch with technologies. I like to play with technologies, and I like to explore in technologies. Along with that, over 3 years I have been working in the big data space. The first time 3 years back I got introduced myself to this elephant, I would say a big elephant called Hadoop. And I fell in love with it. So since then I have been working, I've been living with day in day out I have been living with big data and Hadoop. I have actually built a platform in one of the company where I worked to solve some of their requirements in big data using Hadoop technologies. Okay. Apart from that, I also, as I said, I love to meet people who are working or who wants to acquire knowledge in this space. So I also do a lot of conferences. I get to meet with people who are having similar interest, and we do a lot of get-togethers, online or offline. Whenever we get a chance, I like to meet with such people and share knowledge that I have with them and also learn from them. Right, and that is one of the reasons why we are meeting here. Apart from my daily work, I also love to train people in these technologies. So I conduct a lot of professional trainings in these technologies, and I am also a trainer for these technologies. Along with that, I'm also a Hadoop consultant. So I do a lot of coding in Hadoop. I do a lot of product development in Hadoop for many companies. Right. So that's pretty much about myself. The agenda is basically, today's agenda is, as I said, we will understand big data. I would like all of you to kind of introduce with big data. What is big data, or how do we define big data, right? And why big data is such an important buzzword in the market. Why industries are going towards investing huge amount of monies in this space, right? They are ready to spend enough money to solve their business problems in big data, and we need to understand why is the case. Once we understand what is big data and why big data is so much important, we will get into the next topic, which is motivation for Hadoop. So there, once we know that what is big data and why big data, we definitely need to understand, okay, what are the technologies that are available which I can use to solve some of the big data problems, right? And here there were already some traditional large-scale systems available in the market, but they were not very efficient to work with big data. And that is, and those are the gaps that has been filled by Hadoop. Hadoop has become how Hadoop has addressed those requirements and become the most efficient technology to work with big data. So we'll understand that. Now here, in the interest of time, I would try to keep it at a high level. But if we decide to meet again in our actual trainings, I will make sure that we will understand all the topics in detail, and I'll cover all the topics of Hadoop in detail with a lot of hands-on and lab sessions, so that we can appreciate it better. Okay. So once we know that, okay, what is Hadoop and why Hadoop is useful, we will probably get into some of the Hadoop ecosystem components. We'll touch base on the functionality of each component in Hadoop ecosystem, and that's where we would like to end today's journey, right? So that's the agenda for today's session. I hope you all will enjoy this session, this journey for about 1 hour that we have scheduled. So let us start with big data. As I told you, in the interest of time, I would not be asking too many questions to all of you. Otherwise, I would love to hear from all of you for each topic. But make sure that if you have any doubts and if you think that is very important to be solved, let me know. I would try to answer that. Okay. All right. So what is big data? Again, as name suggests, most of you have guessed it right. Big data is lots and lots of data. It's terabytes and petabytes of data, right? But there are more dimensions attached to big data. I cannot just say that if I have a huge amount of data which is in terabytes or petabytes of size, I can say that it's a big data. There are a lot of other dimensions that I need to also look into. Now, before we get into defining a big data, let me also tell you a couple of big data sources, right? How they are, generating big data, and what are the use case that they are trying to solve. So you can see in this particular document, there are two pictures that I have shown here. One is airline industries, and another one is stock exchange, a famous New York Stock Exchange. So the airline industries that I have shown here, I just wanted to, this is the fact that I just wanted to, share that fact with all of you. An airline jet collects about terabytes of sensor data for every 30 minutes of flying time. There is a system called black box system in an airline or in any flight aeroplane, and in that particular black box system will collect, when it takes off during its flying time, it will collect lots of sensor data informations and store it in that black box system. Now these airline industries are using or analyzing this information to solve a lot of business use case. One of them is, they want to basically improve their performance of a flight. How do I make sure that I will have a cost-effective flight journey, right? So let us continue. I was just trying to tell you that, okay, so airline industries is using and analyzing this data to improve their performance, and service quality. There could be many other use cases that they are solving using this data. That use case could be, they want to identify how do I make sure that I have a cost-effective flight journey. How do I make sure that there will be security? Okay. So what I was telling is there are a lot of use cases that airline industries is solving using this big data that they are generating every flight time. Okay. Similar to that, there is another use case called New York Stock Exchange that I have put here. Well, there are other stock exchanges like Bombay Stock Exchange, or for that matter any other country's stock exchange, and you know that typically a stock exchange means people are trading every other minute. They are transacting huge amount of money every other minute, and they are buying and selling stocks. So the data that it is generating is again huge. It's in terabytes of size for every day. Now when they do that, these data which is collected by these companies, stock trading analytics companies, what they do is they will analyze this data to determine trends for optimal trades. And there will be a lot of high-speed trading algorithms, frequency trading algorithms, which are written by these analytics company who analyze stock data, trade data, to predict the stock behavior for any company. Now, a lot of investors who are having huge money and they want to invest it in a right way, they will consult this company and they make sure that you tell me where should I invest so that my money gets I will get better returns. So to do that, these companies will have a lot of high frequency trading algorithm written, and these algorithms basically do the analytics by analyzing this data which is being generated, right? And imagine that how critical and accurate the analytics should be so that they will generate revenue. Otherwise, if I can, if my algorithm doesn't perform better, I will lose the money, right? So that should not be the case, and that is why it is very critical for them to analyze it better. Another example that I wanted to show you all is Facebook. Now we all know that Facebook being a social media, everyone has a Facebook account these days. The reason I put this example here is again it's a source which generates huge amount of data, since it has billions of users registered across the world. And every 20 minutes on Facebook means lots of link shares, events invites, friend requests accepted, photos uploaded, messages sent. These kind of activities are happening on the Facebook. Well, Divas, I would do that at the end because of to make sure that the bandwidth is intact, and there will not be any disturbance or hindrances due to the voice quality. I have put it off. I will enable it after some time. All right. So what I was telling is, so there are every 20 minutes on Facebook, there is huge amount of activities that is happening by various users that are joined from different parts of the world, and that is again huge data. Now most of you would already know that what is the revenue model for Facebook. They generate revenue through ads, right? Advertisement. But there is one point that I wanted to convey here. We know that yes, through ads they are generating revenues, but earlier days, about 10 years back, the era was, when I say era, the advertisement the industry era was to show the ads to the mass of users, mass set of users. They were not focused on showing to the targeted set of users, showing the ads to the targeted set of users. But with the invent of big data and Hadoop type of technologies, companies like Facebook are actually showing the ads, and this is called targeted set of ads, targeted advertisement, which means you are showing an ad to the right set of users who may be interested to buy these products. I don't want to show ad to a person who is not at all interested in buying this particular product. Now how do I know whether a user is interested or not interested in buying my product, right? To do that, Facebook is analyzing the data that they have, the huge amount of data that they have with all these users, and again they are basically doing a lot of analytics algorithms and make sure that okay, this user is interested in this particular area. For example, if a person is interested in sports, maybe because he is uploading a lot of sports videos, sports photos, he is visiting a lot of sports type of blogs and pages, he may be having a lot of groups whom he have joined which are related to sports activities. So that by analyzing those information about a user, they find out that okay, this particular user is very much interested in sports activities. Let us show him an ad of a company who's trying to sell a sports products, right? And the chances of this person buying this or visiting to these companies is more than a person who is not at all interested in sports, right? So this is called targeted ad, right? And imagine, and this is why Facebook is generating huge amount of revenue. Now imagine that how critical or efficient analysis it should be for Facebook so that they make huge amount of revenue, right? And that is where they are also using Hadoop as an underlying technology, and they do analysis very accurately so that the revenue will be increased. Sudhanshu, so the structure of images and videos, there are some, we are going in detail, but there are some analytics algorithms where you have a sequence file format type of data. You need to basically convert all your unstructured data into that format, and then you need to write a lot of MapReduce programs which internally use a lot of machine learning algorithms to analyze this data, right? So those things we can discuss when we get into those topics in detail. Okay. Similarly, there is another example of a Twitter, and Twitter also makes revenue out of advertisements. In US, many companies who wants to market their products, they use Twitter as one of their platform, because Twitter also analyze the data using Hadoop technologies accurately, so that if I want to market my products, I will be confident that it will reach out to the right set of users or right set of probable customers, right? So Twitter is also doing that, and they are generating revenue. So let us now try defining a big data. Big data is a data which can be categorized into these three buckets. Now, there are famous three V's called volume, velocity, and variety. Okay. Now let me explain each of them. Now when I say I have 1 terabyte of data or a 1 petabyte of data, it's a huge amount of data. Can I say I have a big data? Well, the answer is no. I also need to look into some other dimensions to it. The other dimensions could be velocity, which means how fast the data is being generated in my system. So if I say that I have 1 terabyte of data which is being generated after every 1 year in my system, I can say that that's not a velocity at all, because the speed is very low, right? So that is not a velocity. But versus if I say that, I can say that, the data which is being generated in my system every other hour or every other minute, right? Then yes, I can say that yes, the velocity is there and the speed is there. That means I have huge amount of data which is being generated very fast in my system. Then I can say yes, velocity is also there. Now the third dimension is called variety. Variety means you have three types of data: structured data, unstructured data, and semi-structured data. Any data that you can see in this world can be categorized into one of these three types: structured data, unstructured data, and semi-structured data. Now what is structured data? A structured data is basically any data that you can store it in the form of tabular formats like rows and columns and tables. Many people who have worked in database would know that your relational database management system like Oracle, MySQL, SQL Server, or Derby database, right? All these databases, you store data in the form of tables, rows, and columns, right? So these are called structured data. You basically have a proper structure attached to it. If I can say that get me the name of this particular employee, first name of this particular employee, I can rightly get this particular value of that name, right? So basically I have a structure attached to this value. Now what is unstructured data? Unstructured data is, I think Sudhanshu already pointed out that, a lot of videos, audios, songs, all these video files, audio files. Basically as a Facebook user, I may upload a lot of photos in my profile, right? A lot of videos in my profile. So these are basically unstructured data. These are just raw stream of bytes, but there is no structure attached to it. These are just, plain stream of bytes. So these are called unstructured data. Even for that matter, right, any application which is hosted in your production environment, you can see that the logs are being written for these applications, right, every other second or every other minute. And these log files are also having an unstructured data, because any part of your you know any part of your application, when people or users are trying to use them, it could throw some error, it could throw some information that okay, this stage users have completed this many actions, something like that. So based on the debug statements, based on the information statements, the logs are being generated for a particular application, and these logs does not follow any structure, right? So this is called unstructured data. Now the third type of data is called semi-structured data. The semi-structured data is something where I can take an example of probably the most accurate example of a semi-structured data would be XML file. XML file has parent-child tag relationship, right? Which means there is some structure attached to these tags. But when you try to put a value inside these tags, there could be anything that you write. There is no structure to it, right? So there is no structure defined to the value part that you are writing, but there is some structure defined in the parent-child tag relationship that you have in XML. That is why it is called semi-structured data. Similar to that, you have a JSON file, right? JSON objects. These are also called semi-structured data. So these are the examples of different types of data. So now when I say that I have a terabytes or petabytes of data which is being generated very, very rapidly, very fast in my system, and it can have any type of data, semi-structured, structured or unstructured, then I can say that yes, I can characterize this data as a big data. Okay, so that's the definition of big data which IBM has defined. I would also like to add two more points here. Recently, the big data has actually gone and I mean the definition has been extended by two different V's. Okay, it has two more V's now. One is called veracity and the second dimension is called value. So basically, these two dimensions have been, I mean the definition of the big data has been extended. Okay, so that doesn't mean that the old definition is not true. It is still valid. Only thing is now people are extending the definition of a big data to increase two more V's as part of that. So what is veracity? Veracity means any data, I mean, so for example, you write a lot of blogs, or you may write a lot of tweets in your Twitter about some topic, right? So you may have some junk characters inside it. You can just, if you are angry for some topic, you may have some bad words, but you don't want to write it, so you will say asterisk something, hash at the rate, something like that. So you may write a lot of junk characters in that. Now how can I find out that when I have a huge amount of data gathered in my system, I need to know that what is this noisy word, right? How many noisy or stop words are there in my data, so that I can remove them when I am analyzing that. So that is called veracity. I should be able to remove these stop words or noise words so that I can have a better prediction when I analyze the right set of words, right? The second, the dimension which is introduced is called value, by the way, which is the most important dimension as part of big data. The companies or the people who are doing business, right, they just want to make sure that the value has to be there, which means, okay, fine, everything is fine, you have defined big data, what is the value out of it? That means whether this data which I have gathered in my system, does it make any sense when I analyze it? Does it really make any sense and bring me some value for my business? If not, it is not at all useful to me, right? So the companies will also analyze the value part of it. If it really makes sense for me to gather the data of, let's say, Twitter or Facebook type website for my business to succeed, then only I should have them as one of my big data. Otherwise, I just chuck it off. I don't really need that, right? So that is called another dimension. So this is how we are basically defining a big data. So are we fine with big data concepts? What is big data? So Sudhanshu, determining the value of the data means there are product team of an organization which will analyze this data. There will be data scientists, dedicated data scientists available who have the domain knowledge of a data, right? If I'm solving some business use case, they are the experts who knows how to find a pattern from this data. And if they find out that this data is junk, even though it has volume, velocity, variety, everything, but I cannot make any sense out of this data, it is not useful for my business use case, then I don't see any value out of it, right? So they are the ones who will determine whether the value is there or not. All right? Okay. So great, thank you. I'm sorry, I think I missed one question here which Anup has asked. Sorry to interrupt, what is the Apache Big Data? Okay, basically it is a big data. Apache is actually owning the all the open source community, so they are doing some advancement to big data. That's it. But conceptually it is the same. Okay, so unstructured data is exploding. This is the slide that I have just portrayed here. If you can see in this slide, early 1990s, or I would say early 2000, late 1990s, there was a very huge amount of volume, right? In this space, if you see, right, very less amount of volume of data was there. It is just a transaction data. So people used to just write some complex logic to solve some business use cases. But over from early 2000 onwards, right, this particular piece has been increased like anything due to the because of the internet as a primary driver, of course, but due to a lot of devices which are there in the market, like smartphones, tablets, laptops, all the gadgets which support internet, right? Through them you can access internet. So people are doing lots and lots of activities by connecting to internet and generating data every other minute, right? So that is the reason why this data is increased like anything. And by the way, the major component of this data is unstructured data. And there is a prediction that even that will grow by far to about 1.2 zettabytes this year. So it is keep on increasing, and that is where all the industries, all the companies have identified that there is huge amount of data is there, lot of unstructured data is there, but let us find some meaning out of it to remain competent in the market. And if you can do that, we may probably have a better business. So that is why these companies have found out the opportunity to analyze the data and to do some business use case out of it to remain competent in the market. So now I would talk about some of the common big data customer scenarios. I have actually taken a couple of industries which basically which would solve some big data use cases by analyzing this data. Okay, I would not go and explain each and every use case. I may take a couple of them in the interest of time, right? But in actual sessions we used to basically go over each and every topics. Okay, so for web and e-tailing industries like eBay or Flipkart or Amazon, right, these are the e-commerce companies. Now they are using big data extensively. Why are they how are they doing it and why are they doing it? So I'm sure all of you have done online shopping, right? People who are joining outside India may have used eBay or Amazon extensively. People in India would have used eBay or Flipkart extensively, right? So these these e-commerce companies are basically online shopping companies, and when you do some shopping with them, next time when you log into these websites, right, you can see that there will be some recommendation tab which will be shown at the below or any part of the page, right? Now here you would be you would be surprised to know that these recommendation page would tell you the products which you already have bought. I mean the similar category products or similar price range products, right? Or you have already visited or served on these websites. So why I mean, and also the trend says that these companies are predicting it such an accurate way so that they will give you the better offers in that recommendation tab. And if let's say I'm a user and I have not made up my mind to buy any product, but casually I'm visiting these sites, I may see some product which is of my interest in this recommendation tab, and I may go to this tab, visit these pages, and I may end up buying this product, right? So the stat says that the hit ratio is about 60 to 70%, which is like huge. That means a user who is not at all prepared to buy such product at the end up buying the product, right? So that is a huge business for all of these companies. And imagine how attractive, how they make this so attractive for the users. And to do that also they need to analyze the data that is there with the users. I mean all the historical transaction data that user has with these companies, with these websites, right? They analyze that and they make sure that okay, user is interested in particular area, right? So they recommend products to them, right? That there is a machine learning technique called recommendations, and they use a lot of machine learning algorithm to come up with the recommendations. So that is one such use cases. There is another type of industries, telecommunication sector, where they typically analyze big data to solve many use cases, but one of the best use cases, customer churn prevention. Now I would say this use case is very important for anyone who wants to do business. Customer churn prevention is a use case where a company want to know that why my customers are leaving me, what are the reason that they are leaving me, right? Can I do something so that they don't leave me? Can I give them a better offer so that they don't leave me, right? That is all about customer churn prevention, and that is true with everyone. That's perfect. That's right, Nishant. Google, for example, you have used Google for your search, right? I mean, Google has become like, everyday activity. Everyone searches on Google. Now you can see that search quality, right, has been improved. People do searches, and as and when you type, right, the search category will be refreshed automatically, right? As and when you type a keyword, it will be refreshed. So that is called contextual search. That is, the feature is called Google Suggest, but Google is doing that dynamically by analyzing the historical search data that is there with them, and they are accurately doing it, and they are doing it so fast using big data and Hadoop framework, and they are also doing a lot of machine learning in that to improve their search quality, right? So obviously Google is using this extensively. Google's are, by the way, the first ones who come up with the idea of MapReduce and HDFS. Basically they are the ones who have built the core components of Hadoop. Alright, so let me go to the use case that I was explaining. So there are companies like, probably in India I would say companies like Vodafone or Airtel. These companies are basically they are the service provider, telecom service provider. So for example, if a company like Vodafone, if some of the users are leaving them and joining Airtel, they want to know why they are leaving. There could be reason that their service quality is bad, or their network is bad in the area where user is staying, or they are not giving a better offer, right? So with any such reason, they basically don't want to stick with Vodafone, and they may want to leave it to their competitors. So by analyzing these reasons and this data that are there with Vodafone, they will come to a conclusion that okay, the users are not interested because of so and so reasons. Let us make them better attractive offer and make sure that they will not leave us, right? So that is called customer churn prevention. And to solve that use case also, they are analyzing the data that they have. So these days, by the way, analysis is very important. Analysis of a data is very important in these days, and many industries are trying to build intelligence in that in the domain that they are working on to analyze the data and to solve some business use case. Government is one such example. By the way, Indian government, I would like to take an example of India. No offense to Indian government, I really admire and respect them, but I was surprised to know when they said that they are also using Hadoop extensively. I have gathered the facts, and Aadhaar card, all the Indian people would know about Aadhaar card. People who are not Indians, let me tell you, Aadhaar card is something which is very similar to social security number for the people who are in US, right? It is an individual identity number, unique ID number for everyone in that country. And similar project has been implemented in India, which is called Aadhaar card. And to implement that, they have used Hadoop, HBase, and all the Hadoop ecosystem components as an underlying framework. Okay, so that is one such use case. In the healthcare industry also, they are doing a lot of analysis to do gene sequencing, DNA profiling, you know, to identify the people who are involved in the crime, mostly the crime related use cases where DNA profilings are used, and some companies or some security agencies are again using analytic algorithms and big data to solve such use cases, right? There is also other use cases like drug safety. So let's say if a company who wants to, next bio type of company who wants to, let's say, introduce a new drug to the market, how do they make sure that, you know, whether this drug will be effective or not? They will do a lot of testing in their in-house testing will be there, but after that, ultimately when it goes to the market, they need to also make sure how do they improve upon that product, right? To do that, they will find out, they will collect a lot of survey information, gather a lot of stats, how this drug is performing in the market, whether it is really solving the elements which is it made up for, does it have any side effects, does it really giving a good results, all these stats that they are collecting from different hospitals, and then they are basically, you know, analyzing this information to make sure that how do we improve on this product, right? So that is one such use case. Dr. Manish says, is Google using Hadoop since start? If not, then what Google was using before Hadoop? I mean, what options we can use instead of Hadoop, and what are the disadvantages and advantages? Okay. Manish, if you can hold on to your question, I'll just cover that, you know, in a while, that, you know, what are the other options that were there initially and how Hadoop solved these problems. Okay. I'll just cover it in a while. Pravina says, what are the limitations of Hadoop? Just hold on to your question, I'll cover it in a while. Okay, so I think enough of use cases. Again, the financial industries also will solve use cases like credit scoring and analysis. A person, so I'm sure the famous US recession that all of us know, where people have become defaulters to the whoever has taken loan from the banks, and that was one of the major reasons why economy was collapsed, and, you know, people are basically suffered from this recession. So that is the reason why banks have started using big data and analytics to make sure that the loans are given to the people who are eligible for it by analyzing their credit score, and they are also using a lot of machine learning algorithms to analyze the historical transaction data that is there for each user to make sure that, you know, they basically give the loan to the people who will be eligible to pay that, and there will not be enough defaulters, so that way they can save money. Okay, so these are the various use cases that are there with this industry, and there are many more. The list is huge. There are a lot of industry sectors who are doing big data analysis in various areas. I've just captured some of them, right? And by doing so, obviously insight into data can give you a business advantage. I have just talked about recommendation as one of the technique that retail industries use, like Flipkart or Amazon, to make sure that if I can recommend some product, they will buy it, and ultimately I will increase my sale, right? Similarly, some key early indicators can mean fortunes to business. So customer churn prevention is one of the good use case of this statement. If I know my customers are leaving me, if I can give them a better attractive offer, they will not leave me. So if I upfront know that, okay, these are the problems, I can solve them upfront and prevent a loss to my business. And more precise analysis will be done by analyzing all this data using Hadoop. Okay, so what big companies have to say? This is just for your information. There is nothing to understand much, but big companies like McKinsey, Gartner, who are very you know, highly I mean, they are basically the top researching companies, consulting companies, who analyze each and every software product in the market and compare the results of them with the other products. So they are also recommending Hadoop to use Hadoop in big data analytics, and they are also saying that the big data analytics is the next big thing in the market. Some of the users of Hadoop, these are the companies who are using Hadoop extensively, but there are lots of companies in the list. The list is huge. I've just captured some of the stats here, like how each company is using Hadoop cluster in their environment, like 1100 machine cluster and all. So this is mainly about how they are using Hadoop. What is the configuration of the Hadoop cluster and each node that they are using in that organization. So for example, Facebook, they have 2 major Hadoop clusters and 1100 machine node cluster that they have. Okay. Yes, Shweta. So who can learn Hadoop? Are there any prerequisites? To people who want to be a developer or data scientist in Hadoop and big data, who want to work in big data and analyze the data, who want to write some programs to or algorithms to analyze the data, they all can learn Hadoop. Okay. Even people who want to become a data analyst, right, from a product point of view, who want to find out the pattern in the data, can also learn Hadoop. So that's pretty much about the users that are there in the Hadoop. So till this point, are we clear? Did we understand whatever I have covered? Some of the common customer use cases, or the why big data is so much important, right? So what and why part are we clear with respect to big data? Sure, Manish. Dr. Manish, basically, he's an Ayurvedic doctor. And he is also interested in computer and web designing. Okay, that's good. That's fantastic, I would say. There are online courses available to learn Hadoop. Well, you can join us. We are having a lot of Hadoop online courses, Hadoop training available. You can join us. We will definitely help you learn this. Okay. You can contact us after this training and we will help you. We will be happy to help you on that. Okay, so I would now quickly cover some of the, okay, sure. So Dr. Manish, let's talk after this session. You can definitely shoot a mail to support@WizIQ or courses@wiziq.com. If you want to contact me directly, by the way, any of you who want to contact me directly, you can just write a mail to consultjamin@gmail.com. This is my personal email ID. Probably I would help you in some of your questions if you have with respect to big data and Hadoop, right? All right. Okay. Thank you, sir, Sanjeev, for your information. Okay. So motivation for Hadoop. Now we all understood what is big data and why it is so much important. Let us spend some time in understanding, why Hadoop has become the most effective technology to work with big data, right? So traditionally there were some technologies, large-scale systems available, which were also designed to work on big data platform, but they were not efficient enough to work on big data, and we'll see what are the reasons why they were not efficient. So by the way, traditionally the competition has been processor bound. The significant amount of complex processing was done, and primary push was to increase the processing power of a single machine. Faster processor, more RAM. But as and when the data was generated and more data is coming, right, the distributed systems were introduced. Distributed systems evolved to allow developers to do a lot of such programming. So for example, what is distributed system? By the way, let me just give you a brief intro on that. Let's say I have a 1 terabyte of data which I want to read. So if I want to read 1 terabyte of data, let's say if I store, there are two use cases. First use case is, let's say I store it in one particular machine, single machine. It has 4 IO channels, that means 4 hard disks. Each hard disk has 100 Mbps read speed. If I want to read a 1 terabyte of data from these different IO channels, it will take about, let's not worry about the calculation mathematics involved in that, but let's just say that it will take about 45 minutes to read 1 terabyte data from a single machine, which is huge. Okay, but in in that case, if I can store this 1 terabyte data in 10 different machines, right? Again, the same configurations of each machine, 4 I/O channels, each channel has 100 Mbps per speed. But if I can distribute my data and store it in 10 different machines, can I read faster? The answer is yes. I can definitely read faster in about 4.5 minutes. Okay. So that is the major motivation behind distributed file system. Okay. So now let me tell you, if I have a file which is like huge, right, which is let's say very huge, 1 terabyte in size, and if I want to store it in these kind of different this is, let's say, this is one big distributed system. Okay, this is one big distributed system, but in that system you have actually physical different servers. One is in Chicago, one is in Denver, one is in Houston. So different geographical locations are there for different servers. So when I want to store one huge file, I will basically divide this file into small parts. Okay, so first part will store here, some piece will store here, some will be here, some will be here, and some will be here. That is called, I'm partitioning the data, partitioning the huge data into small parts, and I'm storing it into different machines, servers, right? But when I view them, I can console. As an end user, I will not know that my big file is divided into small parts and actually they are stored in different geographical locations. But as an end user, when I want to retrieve this big file, right, it will be able to show me like this, that okay, it is under this kind of folders. It is in one single directory. It's kind of a virtual directory, right? So that is called partitioning a file, and viewing it as a single file when a user wants to view it. So user will be abstracted out from the complexity of internal storage. User will just think that as if like it is entirely, the entire data will be retrieved from a single machine. So that is the major idea behind distributed file system. I just explained that so that we understand that how are we dividing huge data into different nodes or servers. So let us continue with the topic. What was the problem with respect to earlier traditional systems? So let's say this is one big distributed file system, right? Even for that matter, Hadoop also has internally a distributed file system which is called HDFS, Hadoop Distributed File System, right? So any distributed file system, now I'm going to explain you the problem that were there with traditional large-scale distributed systems. So the problem was, initially when these distributed systems were designed, right, there were a lot of faults or failures that were happening, and they were not very error prone. They were having a lot of failures, and it was not able to automatically recover from these failures. Developer had to do a lot of programming for that. For example, let's say I have a huge file which is divided into small parts. Let's say how many nodes I have, that many parts. Let's say I'm dividing and I'm storing it here. So let's say some piece is stored here, some piece is stored here. Let's say part A is stored here, B is stored here, C is here, and D is here, and probably E is here, right? So now A, B, C, D will make up one big file of maybe 1 terabytes of size. Okay. Now here what I wanted to cover is, let's say this is how, let's say your file is divided. Now for any matter, for any reason, let's say one of the node goes down in this system, and when user wants to read this file, there is, let's say, a client machine or a user machine. When he says that give me this file, in that case, since this node is down, I will not have any access to read this particular part, right? And I cannot give him the entire file. So that was a failure. And to solve this failure, developer had to write lot of programming to support this failure, right? And this is the question to Dr. Manish and some other person who asked that what are the problems that were there with the system and how Hadoop has become the most efficient technology. So since there were failures and developer had to write lot of code to support this failure, even they had to write lot of socket programming to make sure that there is always a connection between different nodes here, right? So that the data transfer is smooth. Even the socket programming is also needs to be written by developer. So imagine that apart from writing a business logic, they also need to write the logic to support these failures, and also to make sure that there will be a communication between these nodes. How this guy knows, the master node knows, this is a master slave architecture by the way, so how a master node knows that the slave node is active or not. So there has to be a communication between all these nodes, right? Heartbeat signal should be sent. Even this has to be programmatically handled, and developers used to handle that. So all these things were very, very cumbersome and very, very time taking activities, and traditional distributed systems did not have support to handle it automatically, right? And that is where Hadoop has actually did a very good job. Yes, whoever is raising a hand, please ask your questions in the chat window itself. That's right, Pradeep. Yes. But not always. Some companies use different setup. Some companies use RAID setup as well. That is actually depends on Hadoop administrator, how do they want to configure that. Right. So I'm just going to explain that if node B goes down, right, of this data is required. That means each block that so basically when I say the file is divided into different parts, I will say that it is divided into different blocks. This A, B, C, D, E are nothing but blocks. So in Hadoop, how Hadoop addresses this is, they have actually created a replication for this. Now let's say there is a B here, that means B should also be here, A will be here, C will be here, D will be here. Like that you are replicating each copy of a block based on the replication factor. If the replication factor is 2, that means each block is replicated 2 times in your nodes, which are there in your cluster. If it is 3, that means 3 copies of a same block will be stored differently in different nodes. So that if let's say this node goes down, I can still have a B block available in one of the live node and I can still access my data. So I will not have any data loss, right? So any distributed system is responsible to support CAP principle, C-A-P, CAP theorem, consistency, availability and partition tolerance. Consistency means if I have a replicated copy like B is here and B is here, and if I write some program, no Sudhanshu, you don't need to have any strong statistical background. If you have that, then you are already an expert, right? So you can just come fresh and learn that. You don't need to have this kind of prerequisites. Yognath, Hadoop is a open source framework. Company doesn't need to buy that. It's an open source. Okay, Shweta, when I say node, it is a physical machine. It is a physical machine, yeah, like your laptop. It's a physical machine. Okay. Nikhil, there will not be any sync between the slave nodes. That is the beauty of Hadoop cluster. There will always be sync between master and slave. There will not be any communication between slave node. Slave node doesn't need to worry that I am storing this particular copy. He just needs to update master, which is called a name node in Hadoop terminology, and name node is the one who takes care of all this, right? So that when we get into the SDFS architecture, we can explain it better. For today's session, we will not cover all these concepts. Okay. So I'm just going to explain now CAP theorem, consistency, availability and partition tolerance. Now here what I want to tell is basically the consistency means, let's say there are 2 replicated copies. B block is stored in 2 different nodes or 2 different machines. I can say that if my program is going to update one of the copy, let's say B become B1 or B dash, okay, that means the another replicated copies of B also should become B dash. It should not be B, otherwise I have an inconsistency in the data, right? So Hadoop takes care of that internally. Another part is availability. Availability, I just explained, if one node goes down, I should not have a data loss, and Hadoop has solved that using replication factor. It will replicate all the blocks by storing it in multiple machines. The partition tolerance I have already explained it in this particular slide. Okay, this is called partition tolerance. Even if my data is partitioned into multiple machines, when I view it, I can view it as a single machine, if it as if like it is stored in the single machine. So there is a virtual layer attached to it, and it will be able to show me all the partition data. Okay. Related to batch and everything, please contact Sanjeev or whatever is showing, right? Please follow that information. He will help you with when is the next batch coming up and what are the course content and stuff like that. Okay. Now there is one more big difference that I wanted to cover here, which is I will just cover that part and probably then we can just move on to the next thing. Just give me a couple of minutes. Yes, Kalyan, we need to read from master only. So that we will understand in anatomy of a file read through a HDFS cluster. I'm not going to explain that right now, but yes, you are right. Answer is correct. Shweta, we will be covering a lot of Hadoop concepts as well as a lot of lab session and hands-on sessions will be there. Okay. So it's not just a concepts and architecture, but a lot of hands-on development will be there. A lot of lab session will be there. Where we will be writing a lot of programs and solving a lot of real world examples. Okay, there is one more challenge that was there with traditional systems and how Hadoop addresses that. Now for example, let's say I have stored the data like this. Okay, let me just erase everything else. Let's say I have the data like this, and if I let's say want to basically process this file, if I want to work on this data and analyze this data, I may write some computation algorithm here in this node. Okay, and when I want to run that, traditional system, what they used to do, since they need to work on this data which is of this file which is divided into these machines, they used to transfer data over a network to this particular machine. Okay, like this, all the data will be transferred to the nodes which are having the computation logic, the computation program. So imagine that if I am working on a terabytes of data, I am transferring terabytes of data over network, right? It is acquiring a lot of network bandwidth and it is not very performance efficient. So how Hadoop solve this problem? Hadoop has done this very reversely. Even though you have, let's say, a computation logic here, instead of bringing data to the computation, Hadoop is bringing computation to the data. It is dividing the computation program into multiple parts, and each program will be sent to the different nodes where data is residing, right? It will aggregate the output of an individual node, individual processing. It will finally combine these individual outputs and then merge them and generate a final output and give it back to the client. So that is the major paradigm shift that Hadoop has done in terms of distributed processing, and that is called MapReduce, right? We will understand in detail about MapReduce when we have an actual training sessions, but this is one major advancement that Hadoop has done with respect to old traditional technologies, right? So there are many more other concepts that we can cover as part of the training, but today just brief intro, so I'm not touching those concepts right now. Okay, so till now, are we clear? Did we understand whatever we talked about? Did we understand the problems that were there with traditional systems and how Hadoop addresses those problems? I need to say this, that I may not go in detail of each and every session, since this is a webinar that we have hosted and we need to stick to the timelines. So apologize for that if someone has wants to know in detail about that, but in trainings we will definitely cover each and every topics in detail. Okay, so thank you for being so patient. Dimitri's the MapReduce program will basically have two phase, map phase and reduce phase. Map phase will work on individual part file, generate a part output, and once these part outputs are generated from each node, they will be aggregated in a reduce phase, and a reduce phase will basically work on this aggregated output to generate a final output. Okay, so that is how a map reduce program works. Okay, great. So this is how the Hadoop history has evolved. 2003, Google has published a paper on GFS and MapReduce. After that, Doug Cutting, who is a guy behind Hadoop, who has written Hadoop framework, has actually incorporated this concept in his project which he was working on, which is called Notch. And then Yahoo hired him. Yahoo and this guy both has developed together a project called Hadoop. And this is how Hadoop came into existence. After that, there were companies like Facebook, Cloudera. All these companies are the regular contributors of Hadoop, and that has become open source from then. Yes, Khaja, this course includes extensive MapReduce programming. Okay, now I am going to define what is Hadoop. I will give you a definition. If you remember this, you will never ever forget what is Hadoop in your lifetime. Okay, so let me tell you what is Hadoop. You just remember this way. Hadoop is a framework which does two things, right? We have been talking about big data, right? So now logically, if you tell me, right, if I want to analyze a data, big data, what should I do first? First of all, I need to find a way to store this data in my system, right? That is one problem. Second problem is, once I have a data stored in my system, I need to process it. I need to process it intelligently, right? So two problems I have. If I can solve these two problems, I can do anything with respect to big data. So Hadoop is a framework which gives me capability to do these two things. It will give me the capability to store data distributedly and process data distributedly. Hadoop does two things: storing the data and processing the data in a distributed manner. Right? Now, to do that, Hadoop has actually two core components. Let me get into that. The SDFS and MapReduce. SDFS is a component which takes care of storing the data in a distributed manner, and MapReduce is a component of Hadoop which takes care of processing the data. Okay, so if you remember this, you know what is Hadoop. Okay, there are many more things that I can talk about. Let me not go there. Okay, there are some key characteristics of Hadoop. Hadoop is reliable, which means it has fault tolerance support. We already seen here, if one node goes down, automatically internally it has capability to recover it, and data is not lost because of the replications and other features that it has. It is flexible and it is scalable, which means Hadoop, you can, once you have a Hadoop cluster set up, let's say you have this different nodes set up as a Hadoop cluster. You can decide right away, Dr. Manish. You can decide right away to jump from Hadoop to traditional system. These days everyone is going towards Hadoop. There is no need of using traditional distributed system because they have a lot of flaws. Hadoop, with respect to MapReduce and distributed storage, it has excelled it in a way, and lots of organizations are migrating their big data processing from old system to Hadoop. They are using Hadoop as a platform to work on big data. Okay, so I was just telling that you can increase nodes here just by adding a node in this cluster. Automatically your Hadoop cluster will work smoothly. You can increase your capacity by scaling it up to different nodes. This is called horizontal scaling, which means if I want to add an extra node or extra machine in a Hadoop cluster, I don't need to restart the entire cluster. My entire cluster doesn't need to be brought down. right? It will be still up and running. I can seamlessly integrate an extra node and it will start working as a one node in Hadoop cluster. Okay. Economical. Hadoop is economical. There is a concept called return on bytes, ROB. You all would have heard about return on investment, right? How much return do I get if I invest this much money? It's a famous question that everyone would ask. Now similarly, all the industries who want to work on big data, they are asking this question. Return on bytes. Return on bytes. Okay. That means cost of storing a big data in this Hadoop cluster versus once I store it, when I analyze this big data, how much revenue I'm going to make. So the revenue that is being generated versus cost of storing the data. If the cost of storing a data is lesser than the revenue that I'm getting generated, then I can say that my ROB is huge. And Hadoop is mostly giving a huge ROB because it is very economical in nature. It doesn't require very high-end hardware to create this Hadoop cluster. Except master nodes, all the slave nodes can be run on a commodity computer. Okay. When I say commodity hardware or a computer, which means a hardware which is having 4 GB of RAM, which is very much similar to our homemade home-used laptops, which can also be used as one of the slave nodes in Hadoop cluster. Okay. So these are the Hadoop characteristic. Let us go into the Hadoop ecosystem components. So this is the Hadoop ecosystem where SDFS and MapReduce are the core components of Hadoop that we already understood. There are other components. You would have heard about these keywords called Flume, Scoop, HBase, Hive, Pigletin, Mahout, and Uzi. So I'll just give you a very high level intro on these topics. So Flume and Scoop are basically the components. Now let's say you set up a Hadoop cluster, right? What is the first thing that you want to do? You want to store a data. But to store the data, you want to make sure that from where I should bring the data, I should import the data, right? You can have data stored in your relational database systems, Oracle, MySQL server, or you can have a data hosted in your websites like Twitter, Facebook, and you want to extract this data like unstructured data. So to support that, Flume and Scoop components are used. Scoop is used to import the structured data into SDFS. Flume is used to import unstructured data into SDFS. HBase is a layer on top of SDFS. HBase is basically designed to support in-place update. Now here one more thing that I want to tell you. SDFS is a file system. It's a distributed file system where once you write a data, it follows WORM architecture, WORM. Write once, read many times. Okay. SDFS follows this pattern. So once you write one data, you cannot update the data in SDFS, right? But HBase is designed to have that feature. HBase internally store data in SDFS only, but through HBase you can update a particular record in a big terabyte of file because it is storing a data and indexing it, right? So when we get into the detailed sessions of all of this in training, we will understand why and how they do that. Okay. Hive and Pig are the components which are designed especially for the people who doesn't want to write Java programs as a MapReduce programs. Who want to write MapReduce in different language, not in Java, they can go ahead with Hive or Pigletin, right? There are companies like Facebook who has developed Hive and Yahoo who has developed Pigletin, just to make sure that it was very difficult to get highly Java skilled people. So instead of that, let us develop a component which can work on small, very simple SQL type query language. So Hive, if you want to write, if you are familiar with SQL query, you can just write SQL type query in Hive component, and still it will internally convert these queries into MapReduce program, and you can analyze the data. Similarly, if you don't even know SQL query or Java, you can use a custom Pigletin script and you can basically write that script to analyze the data. Internally, Pig engine will convert your script into MapReduce engine, MapReduce framework, and execute it on the Hadoop cluster. Okay, there is another component called Mahout. Mahout is a machine learning library which does a lot of analytics algorithms, and you can use that if you want to analyze data using Mahout APIs. Uzi is a workflow scheduler. It's basically it's a workflow system where if you have, let's say, you have a pipeline where you want to import the data, then you want to run some MapReduce programs, and then you want to create an output. If you want to daily do this job step by step, step 1, then step 2, and then step 3, then you can schedule everything using Uzi. And Uzi is the best workflow scheduler in Hadoop. You can schedule all your MapReduce jobs in Uzi, and you can create a workflow out of that. So these are the high level overview, very high level overview of each and every components of Hadoop ecosystems, and in training we will cover in detail of all these things. Okay, so that's pretty much about it, guys, for today's webinar. I have covered all the topics that I wanted to cover. Let me spend 5 minutes of your time to introduce WizIQ and what all we do in WizIQ. By the way, okay, Yognath has a question. In order to retrieve data using Hadoop, is it mandatory to store data using HDFS, or it is possible to retrieve data from existing structured systems such as SQL Server? So if you want to work on process on data using Hadoop, then automatically you have to store it in HDFS. First you need to bring it to HDFS, and then only you can analyze it. Okay. If you want to use MapReduce program, then you need to do it that way. Yeah, Nikhil, so Hadoop also takes care of security of data. When we understand HDFS architecture, we will know how it is making sure that the security is intact with respect to data. So Yognath, what I said is, if you want to analyze the data which is stored in SQL Server, you need to first bring it to HDFS in Hadoop. Once you store it there, then only you can analyze it using MapReduce programs. Okay, so it is mandatory to first store it in HDFS, and then you can analyze it. Okay, so everyone, I have actually covered whatever agenda topic that we have with respect to big data and Hadoop. I hope you all have enjoyed this session. Was it useful to everyone? Was it fine with everyone? Right. So thank you so much for attending this webinar. I really appreciate your patience to hearing me out for about 1 hour. I hope I conveyed the topic that I wanted to convey to all of you. Thank you, Nilay. Thank you, everyone. Thank you so much. Thank you, Dr. Manish. So just hold on for 5 more minutes. I really want to, cover something about WizIQ. Thank you, Sridhar. Thank you so much. So about WizIQ, we will just, WizIQ is an education online training provider, and it has about so many learners, about 30 lakhs plus learners, and about 2.5 lakhs plus instructors across the world, right? Yeah, Chaitanya, go ahead. Chaitanya, you can ask all these questions to WizIQ team, right? They will help you with all this. Okay, and WizIQ is actually into training different technologies. They are into test preparations and lifestyle management, different languages. They are basically into training each and every skill that you have in the market. So they are the leading training providers, and you can actually read a lot about WizIQ by visiting the WizIQ sites. So now we are open for questions. No, WizIQ only provides online training. Shweta, ETL tools are just for extracting, transforming, and load. So Scoop is one of the ETL component of Hadoop. But once you bring the data into system, right, you also need to do a lot of analysis over it, right? So that capability is there with Hadoop in the form of MapReduce programs. So the ETL tools doesn't do that, whereas Hadoop as a framework supports all these things. Thank you, Kiran. I appreciate that. Thank you, Nikhil. Appreciate that. Kalyan, actually the cost of see, as I told you, Hadoop framework is a open source framework, so you don't need to spend any money to install Hadoop in your system. Okay. Yes, Dimitris, I am a Hadoop instructor and I will do a lot of all-night training on Hadoop. So you can just register for these trainings and I will be your instructor. We can actually work together on that. Thank you, Dimitris. It's 28 to 30 hours of training. So Khaja and everyone, I would request all of you with respect to any question that you have as far as course or training is concerned, please contact WizIQ, WizIQ team. They will help you on that. Okay. Sanjeev will give you more details on that. Okay, Sanjeev has already given the email ID. Thank you, Sanjeev. Appreciate that. So thank you so much, guys. Let's call it a day. I'm going to end the session. Thank you so much for your time again. Let's hope to meet in future.